we've already talked about the law of sines, and the law of sines is great if we have at least two angles already, or at least we have an angle and its opposite side. In the ambiguous case, we only had one angle, but we had its opposite side. Sometimes we may not have an angle and its opposite side, or we may just have one angle, or no angles. And that's where law of cosines comes in. So one thing to note is if you can use law of sines, use it. It's the best way to go. But sometimes, based on the information they give you to solve a triangle, it's impossible to use the law of sines, and so we use the law of cosines. Now, there's three different versions of the law of cosines. If you look closely, they're all really the same thing. It's one of them squared plus the other two squared, and then whichever two are here are also right here, and whatever is out here, its angle is in here. So they're really just three different versions of the exact same thing, and it just depends on which sides they give you in the triangle. There's really no difference in these equations. But for example, if you only know one angle, say you know angle A, you've got to use the first equation. If you only know angle B, you've got to use the second equation. If you only know angle C, you've got to use the third equation. Sometimes with the law of cosines, and we'll see this in a second, you have no angles. And if that's the case, then you can pick. It doesn't matter which one of these you use. You just choose which angle you want to solve for, and you pick that one to start with. Okay, so let's start with an example here. The real key to the reason that we cannot use law of sines is because there's nothing where we have both the angle and its side. Okay, because right here we have side A. So notice we have angle A, but we don't have side A. We have side B, but not the angle. We have side C, but not the angle. So there would be no way for us to use the law of sines to solve this. So we have to use the law of cosines. Now, like I said, you just need to look at what angle you're given to pick which one. So since we have angle A right here, we're going to use the very first equation. So side A I don't know. It says A squared equals, and then B squared. Okay, side B is 20 plus C squared is 30 squared minus 2 times 20 times 30 times the cosine of A, which is 60 degrees. So you can plug the entire right side in your calculator, and if you do, you'll get 700. Then to solve for A, you take the square root of both sides, and let's see what you'll get. Square root of 700 26 point, we'll round that to 5, 26.5. In general, we'll want to round the sides to the nearest tenth and the angles to the nearest degree. So now we do have all three sides and an angle. So we still need to figure out two more angles, and what we'll do at this point is switch back to the law of sines since it's a simpler way to go. So now if you just set up the law of sines, you know that 26.5 over sine of 60 degrees is equal to 20 over sine of angle B equals 30 over sine of angle C. So at this point you can choose to solve for angle B or angle C. It doesn't matter. I'll just go ahead and do angle B. So I get 26.5 times the sine of B equals 20 times the sine of 60 degrees. Then divide both sides by 26.5. And let's see what that gives us. 20 times the sine of 60 degrees divided by 26.5. We get 0.65360. So that's what the sine of B equals. So let me see that again. It was 0.6536. So we get sine of B equals 0.6536. So to solve for angle B, we have to use the arc sine, or sine to the -1. So I do second sine, and I'd encourage you to just do second answer so it'll plug in the exact thing instead of rounding. So we get 40, we round to the nearest degree, so 41 degrees. So angle B is 41 degrees. Alright, so let's go back up to our triangle and mark that. Angle B is 41 degrees. Now the simplest thing at this point to do to solve for C is just do 180 minus 60 minus 41, and I believe you should get 79 degrees. Okay, I'm going to scroll down just a second so you can see that work there at the end just in case you still need it, how we solve for angle B. So unfortunately these ones are a little more complicated. We had to use the law of cosines and then the law of sines, but hopefully it makes pretty good sense to you. Okay, so this is one type of problem. What you're actually going to have, if you look at what we started with, it was side, angle, side. That will be one type of problem you'll have with law of cosines. The other is side, 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 where you have all three sides but none of the angles. So this is the time where you can pick which one you want to use, the first, second, or third equation. So just for the sake of doing something different, we'll use the second equation, which is b squared equals a squared plus c squared minus 2ac times cosine of b. So this will allow us to solve for angle B. Okay, side B is 9, so we'll do 9 squared equals a squared. That's 4 squared plus 6 squared minus 2 times 4 times 6 times cosine of angle B. Alright, so I simplify, get 81 equals 16 plus 36 minus, let's see, 48 cosine of B. 16 plus 36 gives me 52. And one very important thing here, this is a common mistake. You cannot do 52 minus 48 and say 4. The 48 is attached to cosine B, so you cannot do that. You have to subtract the 52 over to the other side. So that should give us 29 equals negative 48 cosine of B. Now we divide both sides by negative 48, and we get this is equal to cosine B. So to solve for that angle, we have to use our cosine, or second cosine, or cosine of the negative 1 if you prefer that. And that there is a negative there. It'll show up again once we move this. Sorry, let me change that to a divided by, negative 29 over 48. And we get 127.168. So we're rounded to the nearest degree, so we'll just call it 127 degrees. So B is equal to 127 degrees. So we'll put that in right here. Now we can use law of sines. So now that we've solved for an angle, we can use law of sines. So we would plug it in, and we would get side A, which is 6, over sine of angle A. And then side B is 9, over sine of angle B, which is 127, equals side C, which is 4, over sine of angle C, which we don't know. So you can solve here for either angle A or angle C. It doesn't matter. I'll solve for angle C just because that's what I want to do. We'll do 9 times sine of C equals 4 times sine of 127, and then divide both sides by 9. Let's see what that gives us. We have 4 times the sine of 127 over 9. We get 0.3549, and then remember, at this point we need to use arc sine to solve for C. So we use sine to the negative 1, that's arc sine, it's all the same thing, of the answer. And we get 20.7, so we'll round up to 21 degrees for angle C. 21 degrees. So then the last step is to solve for angle A, and you know you can just You know that the three angles have to add up to 180. So if you do 180 minus 127 minus 21 degrees, you get your answer, which is 32 degrees. Okay, and if you want some practice on this, if you look at page 628 in your books, that has lots of good practice problems for you to do there.